integrate this, I will get back the derivative. As in, this is the derivative. Integrate this, I'll get back the y. This is the y. Square root of 4x minus 3 is the y.
Oh, you still need to add plus.
Huh?
You still need to add plus.
Yeah, plus c. Yeah. Okay. You understand?
You add plus c for every
When you have the y, which is square root 4x minus 3, I differentiate, I will get dy over dx. So I'll be getting 2 over square root 4x minus 3. And then if I do the reverse, integrate. Okay, integrating this, I'll be getting back square root 4x minus 3, but I must have the plus c. Okay, because there's this whole family over here, right, whereby once I differentiate this, regardless of whatever constant that I have, if it's a plus 2, plus 3, minus 1, minus whatever, okay, differentiate, I will still get the same thing. Because I know that if I differentiate constant, it will give me 0. Okay, so that's why when I integrate, I must take into account that there is all that kind of possibilities. That's why I must put the plus c. Understand? Okay, any questions? Okay, if not, right, I want you to try question 2, exercise 18.1, question 2. Okay, I would like you to do this. half C.
And only
Yeah, mistake. Okay, are we done? Right, you'll get answer 2x over 1 plus 2x over plus d. Okay. So the reason why we're going through this process, okay, it is because we have not found out, okay, how to actually integrate expressions such as, okay, because we have not yet learned how to integrate ax plus b to the power of n dx. Okay, but actually intuitively, alright, it should be the same as how our previous rule actually applies. So same thing. Okay, if I have an expression like this, power plus 1, okay, over the new power. But do you think that is all? Do you think that is all?
Plus C.
Okay, plus c. Is that all? Okay, yes, you need to actually take into account the a as well. Okay, so I need to actually put in the a in this case. Okay, the reason for this, okay, it is because if, for example, I want to let's see, okay. Okay, if I have, for example, okay, for example, I have y to be like that, okay, whereby a and n, they are all actually constants and c is also a constant. Okay, I know that if I were to differentiate this, okay, this is just a constant at the bottom. Okay, so I will actually bring down the power first of n plus 1. Right? Then after that, I will have ax plus b. n plus 1, I need to minus 1. Right? Then after that, I need to differentiate the inside of the bracket, which is going to be the a. Correct? Sorry? Okay, then after that, plus the c. Differentiate the c is gone, right? Okay, so if I were to differentiate this, I'm going to get this. Right? I bring down the power. Okay, power I minus 1. Then after that, I differentiate the inside, which is going to give me a. Okay, then after that, what I'm going to do is that if I want to simplify this, I can cancel that out. And then my final answer will be ax plus b to the power of n. Right? That's all. So correct? Nothing negative. This is all constants. Constants. So you don't need to use quotient rule at all. Yeah. Okay. So therefore, if I want to differentiate this, I'm going to get this. Okay. Then after that, if I want to understand the integration, is going to be the reverse of differentiation. So therefore, I can conclude that okay, the integration of ax plus b to the power of n, right, that will actually give me ax plus b n plus 1 over a n plus 1. Okay, get me back the expression for y. Right? Any questions?
So only X is the
Yeah, x is the variable. Okay, other than that, they all. You understand what I'm saying? Anybody not understanding what I'm trying to say? You want me to give a numeric example? Okay, so for example, right, okay, if I were to have maybe 2x plus 3 to the power of 7. Okay, I know that if I want to differentiate this, I am going to get 7 2x plus 3 to the power of 6. Then after that, differentiate it inside, give me 2. So I just leave it as this first. Okay, so I don't want to simplify at this point. Okay, so what we understood is that I multiply this number. Okay, this one I minus 1. I had the effect of a minus 1. Then also I differentiated the inside. Okay, so this one is the differentiation of inside. Okay, brought down power. Okay, then after that the power over here I minus 1. Okay, so if I were to do integration, okay, integration of this, okay, I will have to get back the reverse, right? So how do I actually get back the reverse? So in order to get this part over here with a plus c at the back, I will need to actually divide the 7 away, divide the 2 away, and then after that plus 1 to the power, which is going to be the opposite, right? So therefore, okay, I will have to consider this entire thing. Okay, I will have to plus 1 to the power. Okay, then after that 6 plus 1, I will divide away the 7, right? Okay, then after I need to actually look at the derivative of the inside. Okay, then after that I divide away the 2 itself. You understand? Or rather the constant or the coefficient of x in this case. Okay? So that's why it will lead us to having this as an answer. Okay? You all understand what I'm saying?
So what if we simplify it?
What if what?
Like
Simplified form?
Like the power is
No, I'm just trying to show how is it that we can get the idea.
don't have power 6, like just the whole thing.
So integrating 2x plus 3 to the power of 6, is it?
No, don't have power 6.
Without power of 6.
Yeah.
Then isn't this normal integration? Huh? What are you trying to say? You understand your question? Okay, so if I were to be just integrating, for example, the power of 6, I just have to actually plus the power 7 divided by 7. Okay, then after that divide by 2 also. Okay, then plus c. Okay. What can I erase and what cannot erase? Can I erase already? Yeah? So let's look at try 6. Okay, so try 6, we want to integrate 2x minus 9 to the power of 4. Okay, So we would actually plus the power first. Bring down the power. Alright, then also the coefficient of x. Okay, then after that for part B, if I want to integrate this, okay, so I need to actually readjust this expression to make it into negative index first, so that it's easier for us to integrate. So 3x minus 1 to the power of negative 3, okay, we would actually plus 1 to the power then bring down the negative 2 as well as the 3. Okay, then after that plus c. So we simplify our answer. And we will be getting that. Take note that in this rule over here, right, n cannot be equals to 1, neither can it be equals to negative 1. Okay, because if n were to be equals to negative 1, that means we're looking at the 1 over ax plus b. Okay, that one we'll be looking at it at a later chapter, okay, later part of this chapter. Then after that, when n equals to 1 itself, okay, that is no different from just integrating our expression ax plus b. Alright? If n equals to 1, we're just integrating ax plus b. So there is no need for us to apply this rule. We are just integrating very simply. Okay, if n equals to negative 1, so if n equals to negative 1, we'll be looking at ax plus b to the power negative 1. Okay, this one, we will look at it at a later part of this chapter. Right? Okay, this rule will not be able to apply if the power is negative 1. Right? Yes. Okay, that one we look at the logarithm. Okay, so I'll just end off over here. Tomorrow we will continue, right, to look at certain problems on in-depth integrals.